Hello and welcome to Maths on the Move, the podcast from plus.maths.org. I'm Rachel Thomas. My colleague Marion Freiberger and I are very fortunate to work with many amazing mathematicians. And in this run of podcasts, we've been revisiting our 2017 interviews with the 6 female mathematicians from the University of Cambridge, whose portraits form part of the Women of Mathematics photo exhibition. Today's podcast is the final one of this series, and we're really pleased to revisit our interview with Carola-Bibiane Schönlieb, now Professor of Applied Mathematics and a very good friend of us here at plus.maths.org. Carola works on the interface between machine learning and the mathematics of image analysis. She leads so many fascinating research projects, we tend to lose count. But recently, we've covered the work of Carola and her colleagues on how artificial intelligence can support medical doctors in their work, and a collaboration with Indian researchers on how machine learning can make sense of the vast amounts of remote sensing data we now have available in order to help conserve forests and improve life in cities. We'll give you some links to that coverage at the end of this podcast. Now, every time we work with Carola, she highlights the broad range of mathematicians and other researchers she works with. And as you'll hear in this interview from 2017, it is this collaborative nature of mathematics that Carola loves.
Hello, Carola.
Hello.
Shall we start by you introducing yourself, please?
Yes, so I'm Carola Schönlieb. I work here at the Applied Mathematics and Theoretical Physics department. I'm a reader in applied and computational analysis and have a group on image analysis here in Cambridge.
How and when did you choose to do mathematics?
So that's interesting. So I went to school in Austria, in Salzburg, to a gymnasium, which is like doing A-levels here, I guess. And actually the gymnasium where I was at was specialized on languages, which turned out that I really don't have a talent for. So I was always quite interested in mathematics, and I was just, I guess I was just reasonably good in it. During school, so it was a natural choice for me to do it as university studies afterwards. When I graduated in school, my head teacher then gave me a book as a present, which was Fermat's last theorem from Simon Singh, which I read then over the summer, and I thought, wow, I mean, this person just spends years of his life proving one very simple statement, and then it turns out that it's like pages of proof that is involved to verifying it. That left a deep impression on me, and then I thought, okay, so this is really the right choice. Let's just go for it. I'm not a pure mathematician myself now, actually, but this was really something that I thought this must be very fascinating if someone spends years on one question.
So you say you're not a pure mathematician. Can you explain what your area of mathematics is about?
My background is in partial differential equations. I use in particular partial differential equations and so-called variational methods, which means you're minimizing an energy, optimization problems, basically. I use these mathematical tools for inverse imaging problems, meaning that you have either a measurement of an image or you have an image itself and you would like to extract some information from these measurements. Could be, again, an image, so think about image denoising. You're measuring a noisy image, you want to compute the denoised image. Or it could be you get an image, you're not interested in the whole image, but you want to segment certain parts in this image. Or when I said measurements of an image, it could also be that very often in medical imaging you're not measuring an image directly, but you measure some indirect transform of this image. In magnetic resonance tomography, for instance, that's connected to the Fourier transform. So you get Fourier measurements, and then you want to reconstruct an image from these Fourier measurements.
Okay, so it's basically you have information about an image and you want to extract an image.
Yeah.
Good. So could you tell us one of your favorite mathematical moments, mathematical experiences?
Okay. So I think there are many and very different moments that you experience during your research. I think really the best mathematical moments appeared during my research work. Maybe I don't know if there is really a best one, but what I appreciate a lot is this process when you start thinking about something, and it takes you a long time till you understand it. This is often a kind of torturous process because usually these things. So this is one of the challenges, I guess, of being a mathematician is that you're always faced with these really difficult problems. And but then actually, this moment when all of a sudden you get an idea in this process of trying to understand the problem and finding out how to solve it, to get an idea and then follow this idea through and see that it actually works. This is really cool. Yeah.
So, related question: like, what are the joys of doing mathematics, and what are the challenges?
So I think the joys are really when you succeed. These are really the joys. So when you succeed and when you see that what you have done is interesting, and also not just interesting for you but for other people. So you go to conferences and you present what you have done, and people are excited about that. People read your papers and you get emails about, this is really interesting. Have you thought about this or this? So this is something that I enjoy quite a lot. I enjoy also quite a lot to work with students. In particular, doing research with students, I like that also a lot. So actually collaborating in general is a wonderful thing for me in mathematics, because especially if you meet people that are on the same wavelength as you are and that are still complementing you, so you can discuss mathematics very freely. Discussing mathematics, I think, is something very personal. And you really need to trust the other person to openly sometimes reveal that you have no idea about it. And I think only this way you can make progress and actually solve problems. But this collaboration and this personal level about mathematics I like a lot. And the challenges I think are we really have to work on very hard problems, and you need a lot of patience to do that, and you need a lot of confidence, which is often not so easy. So you have to deal with the fact that sometimes you might not be able to answer a question like that. Maybe you will answer a question a year after you have started thinking about it. Maybe you have still not solved it now. And I think this is something that is challenging for the person. So again, on a very personal level, because your research is really your research, and it's your question, and it's you who has to solve it. And if you can't solve it, you still should, keep believing in yourself. So I think this thing with confidence is a very important challenge to overcome, and to get to know your own strength and your own weaknesses, and to really exploit your strength and maybe work a bit on your weaknesses. But yeah.
And what's it like being a female mathematician in particular?
So there was a time when I did my undergraduate studies, I didn't realize at all that this makes a difference. I thought, and I really never thought about it. Then when I started to do my PhD, I, for the first time, was sharing an office with another female PhD student. And then I thought, wow, this really makes a difference. It's really nice, actually, to not always be the only one. I think, so this is this is one thing I think that we should really pay attention to, and this is one of the key things why it's important to increase the number of women in mathematics, because it changes the environment. And it's just nice not to be a singularity all the time. Yeah.
Yeah. And what advice would you give to a young woman that wants to become a mathematician?
So an important thing, as I said, is to get to know your strength and to believe in your strengths, and to really accept your weaknesses, and don't pull yourself down for your weaknesses. I meet so many female mathematicians, students, and also women who have already achieved a lot, who are still thinking that and still saying that they might not be good enough, and that's really this is really killing you if you don't get rid of this. If you and there is no reason to believe that actually everyone has their strong points and their weak points, and I think this is just something that we have to overcome, to really focus on the strong points and then just go for it. And one other advice I would give is planning your career. Again, I only have this with women, that there is this bad consciousness about, following your career and leaving family behind, which you don't leave family behind, but just this point that you have a bad consciousness if you want a career. I just yesterday met an assistant professor in Switzerland, who is a woman, and who her husband has been taking care of their child for the last 2 years. So he was the one who stayed at home. And she said she still has a bad consciousness because of that. And just get rid of the bad consciousness. Yeah.
Okay, well, thank you very much.
That was Carola-Bibiane Schönlieb talking to my colleague Marianne Freiberger in 2017. You can find out more about Carola's work in our recent podcast episode, New Ways of Seeing with the Integral Project, and our recent plus.maths.org articles supporting healthcare with AI and opening the black box. And you can see all the Cambridge posters from the Women of Mathematics exhibition and find out more about their work and their mathematical lives at plus.maths.org/content/women. The music in this podcast is from the band Yusa, and the track is called Plankton. Thanks for listening, and bye-bye for now.